Before we even step onto the mat or pick up a weight, there is a quiet but profound conversation taking place within our bodies. One that begins the moment we choose what to eat before a workout. This seemingly simple act is far more than a routine. It is the orchestration of energy, metabolism, and physiology, a dialogue between nutrients and the systems they support. When we consume food before exercise, we are not merely filling a stomach, but we are providing a carefully timed signal to the muscles, the liver, the nervous system, and even the brain. Carbohydrates, often seen merely as a source of energy, function as immediate fuel for the complex biochemical reactions that allow muscles to contract and relax in precise, coordinated movements. The molecules of glucose that enter our bloodstream from these carbohydrates become the currency of energy exchange, rapidly mobilized to supply power to the muscles and the brain, maintaining not only strength but also focus and coordination. Timing is critical because the digestive system operates on its own rhythm. Too close to exercise, and it competes with muscles for blood flow, creating discomfort or sluggishness. Too far in advance, and the energy has already been stored as glycogen, which, while still available, may not provide the peak performance boost that the body craves for an intense session. Protein, often reserved in common discourse for post-workout recovery, holds its own subtle role before exercise. Consuming moderate amounts primes the muscles with amino acids, not only for eventual repair, but also for supporting ongoing metabolic processes that are active even during exertion. The presence of amino acids in the bloodstream helps stabilize blood sugar levels, contributing to a steadier energy output and delaying the onset of fatigue. In this way, protein and carbohydrates work in synergy, one providing immediate energy, the other supporting the structural and functional demands of the body during movement. This balance is delicate, and the type of carbohydrate consumed can shape the intensity and duration of performance. Simple carbohydrates, found in fruits or lightly sweetened foods, are rapidly absorbed, providing quick energy surges, while complex carbohydrates from oats, whole grains, or legumes release glucose more slowly, sustaining endurance without spiking insulin levels abruptly. Understanding this distinction is a step toward listening to one's body, observing how different foods influence energy, mood, and the ability to maintain form during exercise. Beyond the macronutrients, the quality of food plays an equally important role. Whole, minimally processed foods not only provide cleaner energy, but also supply micronutrients essential for enzymatic reactions in the muscles. Magnesium, for instance, participates in over 300 biochemical reactions, many of which govern muscle contraction and relaxation, while potassium maintains the electrochemical balance necessary for nerve impulses. When we consider pre-workout nutrition, we are not merely considering calories, but the orchestration of molecules that will interact at multiple levels, cellular, tissue, and systemic, to allow for optimal movement. Even a small misalignment in this balance, such as consuming overly fatty or extremely fibrous foods immediately before exercise, can shift the flow of blood away from muscles toward digestion, resulting in cramping, discomfort, or diminished performance. This is why the science of timing is as important as the science of choice. The body operates on rhythms both circadian and metabolic, and respecting these rhythms through thoughtful pre-workout nutrition allows the biological systems to perform as intended. The psychological aspect of pre-workout nutrition is another dimension often overlooked. Eating before exercise is also a ritual that signals readiness to the mind, preparing focus, motivation, and mental endurance. The simple act of consuming a carefully chosen meal can provide a sense of preparedness and confidence, influencing performance as much as the biochemical effects. The brain, which is highly sensitive to glucose fluctuations, relies on steady energy to maintain alertness, reaction time, and decision-making under physical stress. When the mind is alert and focused, muscles follow more efficiently, movements are more precise, and the risk of injury decreases. The interdependence of mind and body in this process illustrates that nutrition is not merely fuel. It is a form of communication, a way to align intention, attention, and action. There is also an element of personalization in pre-workout nutrition that science increasingly recognizes. Individuals differ in how they metabolize carbohydrates and proteins, in gastric tolerance, and in energy needs based on body composition. age, sex, and activity level. One person may perform best with a small fruit and a handful of nuts 30 minutes before a workout, while another may require a more substantial mix of oats and yogurt an hour in advance. Paying attention to how the body responds, adjusting portion sizes and macronutrient ratios, and observing performance over time transforms pre-workout eating from a mechanical task into an active biofeedback, a continuous experiment that deepens the understanding of one's own physiology. This reflective approach elevates nutrition from a prescriptive science into an art of listening to the body, where the consequences of choices, energy, stamina, mental clarity, and physical output are observed directly. Hydration, often integrated into pre-workout considerations, interacts subtly with nutrient intake. Water facilitates digestion and the transport of glucose and amino acids to muscles, while also maintaining plasma volume necessary for cardiovascular efficiency. Electrolytes, absorbed along with water from fruits or beverages, prevent disruptions in muscle contraction and neural signaling. Pre-workout meals, therefore, often combine food and fluid intake in a way that primes both cellular machinery and systemic function, ensuring that the upcoming physical challenge is met with both readiness and resilience. Dehydration, even at mild levels, can reduce endurance, compromise strength, and increase perceived effort, demonstrating the interconnectedness of macronutrients, micronutrients, and hydration in preparing the body for optimal performance. The practical implementation of pre-workout nutrition, then, becomes an act of mindful calibration. It is about aligning timing, macronutrient composition, food quality, and hydration to the specific demands of the workout, while remaining attentive to individual tolerance and preferences. It is a continuous dialogue with the body, observing how energy levels fluctuate, how focus is maintained, and how movements feel during exertion. Science informs us of the underlying biochemical principles, the role of glycogen, the contribution of amino acids, the importance of electrolytes, but it is observation, reflection, and adaptation that transform this knowledge into a living practice. The pre-workout meal, simple as it may appear, becomes a tool through which the body is prepared not only to move, but to excel, recover, and communicate its needs for subsequent performance. Finally, there is an elegance in recognizing that these nutritional choices, seemingly mundane, ripple across the entire physiology. The pre-workout meal initiates a cascade. Glucose enters the bloodstream, insulin modulates its uptake, muscles absorb energy, enzymes accelerate reactions, nerve signals sharpen, and focus emerges. The act of eating becomes a form of partnership with one's own biology, a conscious acknowledgement that performance is a product of both internal preparation and external effort. The foods chosen, the timing observed, and the balance maintained constitute not merely fuel, but a respectful engagement with the intricate system of human health, turning every workout into a dialogue of curiosity, awareness, and harmonious energy. Water is often overlooked, a quiet companion to our daily existence. Yet it forms the very foundation of every movement, every reaction, every heartbeat. In the context of exercise, hydration transcends the simple act of quenching thirst. It becomes a subtle and essential orchestration of biological processes that sustain energy, protect tissue, and facilitate performance. The human body, being roughly 60% water, relies on this fluid for almost every physiological function, from transporting nutrients to removing waste, from maintaining temperature to conducting nerve impulses, and even in the delicate coordination of muscle contractions. Without adequate hydration, even the most meticulously planned pre-workout meal struggles to reach its potential, as the very medium through which glucose, amino acids, and electrolytes travel becomes insufficient to sustain efficient communication between cells and organs. When the body enters a state of physical exertion, the demands on its internal systems amplify exponentially. Blood must flow efficiently to muscles, carrying oxygen and essential nutrients while simultaneously removing carbon dioxide and metabolic byproducts. This process is intimately dependent on plasma volume, the liquid component of blood, which is directly influenced by hydration status. Even mild dehydration reduces plasma volume, leading to a cascade of physiological adjustments. The heart must pump harder to circulate blood. Muscles receive less oxygen, and perceived exertion increases, making each movement feel heavier and more strenuous. These subtle changes, often imperceptible until performance drops, illustrate that hydration is not merely about comfort, but about maintaining the integrity of the body as an entire network of energy delivery and waste removal. Electrolytes, minerals dissolved in water such as sodium, potassium, magnesium, and calcium, add a further layer of complexity to the role of hydration. These ions regulate electrical gradients across cell membranes, which are essential for nerve conduction and muscle contraction. The signals that prompt a muscle to flex, extend, or stabilize a joint are transmitted through these gradients, and when fluid and electrolytes are imbalanced, the communication falters. Cramping, reduced coordination, and early fatigue are the tangible consequences of such subtle deficiencies. Therefore, hydration before a workout is not simply about drinking water. It is about ensuring that the medium through which the body communicates and performs is in its optimal state, ready to support every contraction and every movement with precision. The timing and composition of fluid intake before exercise carry their own intricacies. Drinking too little too late fails to elevate plasma volume adequately, while drinking too much too quickly can dilute electrolytes, potentially causing discomfort or gastrointestinal distress. A balance must be struck, one informed both by the duration and intensity of the workout and by individual physiology. For short, moderate sessions, a modest intake of water alongside the pre-workout meal is often sufficient. For longer or more intense efforts, including those in warmer environments, the addition of electrolyte-rich beverages can stabilize sodium and potassium levels, preventing the decline in performance that occurs when sweat losses outpace replenishment. This nuanced understanding transforms hydration from a simple habit into an act of strategic preparation, a deliberate engagement with the body's internal environment. Hydration interacts dynamically with other pre-workout nutrients. Water facilitates the digestion and absorption of carbohydrates and protein, enabling glucose and amino acids to enter the bloodstream efficiently and reach the muscles that require them. When water is lacking, these nutrients are transported less efficiently. Enzymatic reactions slow, and cellular metabolism is impaired. The subtle interplay between hydration and nutrient delivery underscores the idea that no single aspect of preparation can be considered in isolation. Each component, fluid, carbohydrate, protein, electrolytes, works together in a delicate balance to support performance. Observing how these elements interact provides insight into the elegance of the body's design, where each molecule has a purpose and each physiological process is interdependent. The brain, which is remarkably sensitive to even minor fluctuations in hydration, also plays a crucial role in how we experience exertion. Cognitive function, focus, decision-making, and reaction time all decline with dehydration, and in the context of exercise, these changes can manifest as poor form, delayed responses, and even an increased risk of injury. When the mind is clear, well hydrated, and alert, movement becomes more efficient, technique improves, and the experience of effort is reduced. In this way, hydration is not only about the physical systems of the body, but about the integration of mind and body, creating a state of readiness that encompasses both neural and muscular performance. Drinking water before a workout is, therefore, a gesture of respect for the full spectrum of physiological and cognitive processes that contribute to success. There is also an individualized aspect to hydration that mirrors the personalization seen in nutrition. Sweat rate varies with genetics, fitness level, environmental conditions, and even clothing choices. Some individuals may require more frequent intake, while others may need less. The key lies in tuning into the body's subtle cues, sensations of thirst, the color of urine, or the feeling of energy during warm-up movements. Monitoring these indicators over time cultivates an intuitive understanding of personal hydration needs, transforming what might be perceived as a routine habit into a practice of mindful attentiveness. The act of drinking water before exercise, when approached with awareness, becomes a form of dialogue with the self, a recognition that the body's signals are meaningful and worthy of response. Temperature regulation is another critical dimension of pre-workout hydration. Sweating serves not only as a mechanism for cooling, but also as a means of excreting waste and maintaining homeostasis. Water consumed prior to exercise helps maintain thermoregulation, preventing excessive rises in core temperature that can compromise performance and increase fatigue. When combined with appropriate electrolyte intake, the body can sustain higher intensity efforts without disruption, as the balance of fluid and minerals supports both vascular function and muscle contraction. This interplay between thermal control and hydration illustrates the remarkable sophistication of human physiology, where even a simple molecule like water serves as a linchpin for numerous interdependent systems. The reflective consideration of hydration extends into a philosophical appreciation of the body as a living system. Water, often taken for granted, is the conduit through which life itself operates, and approaching exercise with a consciousness of hydration elevates the act from a mechanical routine to a participatory engagement with one's own biology. Each sip, each measured intake, is an acknowledgement of the body's needs, a preparation that respects the complexity of the systems about to be activated. By observing the effects of hydration on energy levels, mental clarity, and physical coordination, one cultivates a deeper understanding of the intimate relationship between nourishment, fluid balance, and movement. It is a practice of both science and mindfulness, where knowledge of physiology informs daily action and where the body's responses provide continuous feedback. Hydration before a workout also sets the tone for the post-exercise recovery period. Adequate fluid intake ensures that metabolites produced during activity, including lactate and carbon dioxide, are transported efficiently out of tissues and metabolized safely. This preemptive step reduces delayed fatigue, soreness, and systemic stress, creating conditions in which muscle repair, glycogen replenishment, and hormonal recovery can proceed unimpeded. In this sense, drinking water before a workout is simultaneously an investment in immediate performance and in the longer arc of adaptation and resilience. The body, prepared and hydrated, navigates exercise with both stability and responsiveness, demonstrating that the choices made before physical activity echo throughout the entirety of the training process. Ultimately, considering hydration as an essential pre-workout element invites a broader reflection on how the body orchestrates life at every moment. Water is more than a beverage. It is the medium of life, the vehicle for energy and information, the element through which every biological reaction is realized. In preparing for exercise, attention to hydration represents a form of respect for the body's sophistication, a conscious engagement with its needs, and an acknowledgement that performance is not merely a product of effort, but of careful preparation and balanced support. Observing how fluid intake influences strength, endurance, coordination, and mental clarity reveals the subtle intelligence of the human organism, and attending to these needs transforms the act of exercise into a dialogue of science, awareness, and care. As we begin to move, to lift, to sprint, or to stretch, the body does not simply react. It orchestrates a complex symphony of chemical and physical processes, each contributing to the efficiency and effectiveness of every contraction and every step. Metabolism, often reduced in casual conversation to a simplistic notion of burning calories, is in reality a dynamic, adaptive system that responds to the intensity, duration, and type of activity undertaken. It is a dialogue between energy stores, hormones, and cellular machinery where the choices made before exercise, particularly in nutrition and hydration, dictate how smoothly this conversation unfolds. Carbohydrates, fats, and to a lesser extent proteins become the raw materials through which the muscles draw energy, and the timing, composition, and quantity of pre-workout intake influence not only the amount of energy available, but the pathways through which it is mobilized and utilized. During moderate to high-intensity exercise, muscles primarily rely on glycogen stored within them and circulating glucose in the bloodstream. These readily accessible forms of carbohydrate allow rapid ATP production, the universal energy currency that powers muscle fibers. The rate at which glycogen is utilized is sensitive to the intensity of the exercise, the muscle fiber type engaged, and the hormonal environment, particularly insulin and catecholamines such as adrenaline. Insulin, which rises in response to carbohydrate consumption, helps shuttle glucose into muscle cells, whereas catecholamines stimulate glycogen breakdown to meet immediate energy demands. The pre-workout meal, therefore, functions not just as fuel, but as a modulator of these hormonal pathways, priming the body to efficiently convert stored chemical energy into mechanical work. As exercise continues, there is a gradual shift in energy substrate utilization. Lower intensity movements draw more heavily on fatty acids released from adipose tissue, whereas higher intensity exertion increasingly relies on carbohydrates. This metabolic flexibility is a hallmark of efficient physiology, allowing the body to adapt to varied demands while conserving critical reserves. Adequate pre-workout nutrition supports this flexibility, ensuring that glycogen is available for peak demands, while fatty acid oxidation can proceed when appropriate. A mismatch, such as insufficient carbohydrate intake before a vigorous session, forces the body to rely excessively on fat or amino acids, which may slow energy production, induce fatigue, and even impair cognitive focus. This delicate interplay underscores the importance of understanding not only the quantity of fuel consumed, but its quality and timing relative to anticipated activity. The role of oxygen delivery and mitochondrial efficiency is also central to metabolic performance during exercise. Muscle cells contain mitochondria, the organelles responsible for oxidative phosphorylation, a process in which nutrients are converted into usable energy in the presence of oxygen. The efficiency of this system is influenced by prior nutrition and hydration, as well as by conditioning. Carbohydrates provide a rapid source of glucose that can enter mitochondria and be oxidized to produce ATP efficiently, while fatty acids provide a slower but sustained energy supply for prolonged activity. When glycogen stores are depleted or improperly timed, the mitochondria are forced to rely on suboptimal substrates, reducing the efficiency of energy production and increasing the accumulation of metabolic byproducts that contribute to fatigue. This highlights how intimately pre-exercise preparation, including meals and hydration, interacts with the cellular machinery that underlies every movement. Hormonal regulation is another dimension of metabolic efficiency. Catecholamines, cortisol, and insulin interact in a finely balanced manner to control substrate mobilization, blood flow, and energy partitioning during exercise. For instance, during high-intensity exertion, adrenaline accelerates glycogenolysis, liberating glucose for immediate use. Cortisol, released in response to prolonged or stressful activity, promotes the breakdown of proteins and fats, supplementing energy availability when carbohydrate reserves diminish. Pre-workout nutrition influences the baseline levels and responsiveness of these hormones, establishing a metabolic environment that can either support optimal performance or create inefficiencies. The timing of macronutrient intake modulates insulin levels, which in turn affects glucose availability and the ease with which muscles access energy. In essence, the body's hormonal orchestra requires both preparation and precision to maintain harmony during activity. The nervous system is another critical contributor to metabolic efficiency. Motor neurons transmit electrical signals that stimulate muscle fibers, initiating contraction and movement. The efficiency of these signals depends on the availability of energy, electrolytes, and neurotransmitter precursors, all of which are influenced by pre-exercise nutrition. Glucose and amino acids serve as substrates for neurotransmitter synthesis, ensuring that the nervous system can sustain rapid and coordinated firing throughout the workout. Hydration supports this process, maintaining the electrical gradients across neuronal membranes that are necessary for signal transmission. A body deprived of these elements may experience delayed reaction times, poor coordination, and increased perception of effort, illustrating that metabolism during exercise is not merely a chemical process within muscles, but a distributed phenomenon encompassing multiple systems. Lactic acid production and clearance further illustrate the complexity of metabolic efficiency. As intensity rises and oxygen delivery becomes a limiting factor, glycolysis accelerates, producing pyruvate, some of which is converted into lactate. While lactate has often been maligned as a waste product, it is in fact an important intermediary that can be shuttled to other tissues, such as the heart or liver, for further energy production. The efficiency of lactate metabolism is influenced by pre-workout nutrition, as adequate glycogen and carbohydrate availability reduce the reliance on anaerobic pathways, limiting excessive lactate accumulation and delaying fatigue. Additionally, proper hydration facilitates lactate transport through the bloodstream, preventing local acidosis and supporting sustained performance. This interconnectedness of fuel utilization, oxygen availability, and metabolite management exemplifies the intricate choreography of metabolism during exercise. Adaptation over time is also an aspect of metabolic efficiency. Regular training induces mitochondrial biogenesis, enhances glycogen storage capacity, and improves the ability of muscles to oxidize fats efficiently. Pre-workout nutrition interacts with these adaptations, providing substrates that signal the body to maintain and optimize these pathways. A well-timed intake of carbohydrates and moderate protein before exercise ensures that energy is available for high-quality training, allowing the physiological systems to experience the correct stimuli and promote favorable adaptations. Conversely, inadequate fueling can blunt the effectiveness of training, reduce endurance, and impair strength gains. This demonstrates that metabolic efficiency is not a static state but a dynamic quality that develops through repeated cycles of preparation, exertion, and recovery. Observing the subjective experience of exertion provides another window into metabolic efficiency. Perceived effort, mental clarity, and fatigue are intimately connected to how efficiently the body mobilizes and uses energy. Athletes and fitness enthusiasts who consume balanced pre-workout meals often report smoother energy levels, reduced mid-session fatigue, and enhanced focus, reflecting the underlying biochemical harmony achieved when fuel availability, hydration, and hormonal balance are optimized. In contrast, inadequate pre-exercise nutrition may produce early depletion, erratic energy levels, and a sense of heaviness or lethargy, all of which are manifestations of metabolic inefficiency. Paying attention to these experiences reinforces the principle that metabolism is not abstract. It is directly observable in performance, endurance, and the lived experience of movement. The interplay between macronutrient composition and exercise modality further refines the concept of metabolic efficiency. Resistance training, for example, relies on rapid ATP generation through both glycolytic and phosphagen pathways, benefiting from carbohydrates for immediate energy and protein for supporting amino acid availability. Endurance activities, in contrast, emphasize oxidative pathways and fat utilization over longer durations, requiring different timing and quantities of nutrients to maintain peak performance. Recognizing this specificity allows for strategic pre-workout nutrition that aligns with the particular metabolic demands of the session, enhancing efficiency and enabling the body to operate closer to its physiological optimum. Finally, metabolic efficiency is also a lesson in subtlety and awareness. It requires observing how the body responds to different foods, timing, and hydration strategies, and adjusting accordingly. It is a continuous feedback loop where the signals from muscles, the nervous system, and subjective experience inform future choices. Proper pre-workout nutrition ensures that glycogen is accessible, that hormonal responses are balanced, that electrolytes and hydration support cellular and systemic function, and that the nervous system is ready to translate energy into precise coordinated movement. This careful orchestration, largely invisible to the eye, underpins every successful exercise session, illustrating that the efficiency of metabolism is as much about preparation, observation, and understanding as it is about the biochemical processes themselves. The moment the body ceases its exertion, an extraordinary transition begins, one that is as crucial to progress as the workout itself. Post-workout recovery is not merely a passive period of rest. It is a heightened window of biological sensitivity, a time when muscles, metabolism, and even the nervous system are primed for restoration, adaptation, and growth. During exercise, muscle fibers experience microscopic damage, glycogen stores are depleted, and metabolic byproducts such as lactate have accumulated. Hormonal fluctuations occur, including elevated cortisol and growth hormone levels, signaling the body that repair, reinforcement, and adaptation are necessary. How we nourish ourselves in this period, what we choose to consume, and the timing of that intake determines not only the speed of recovery, but the quality of adaptation and the potential for improved performance in subsequent sessions. Protein plays a central role in post-workout recovery, serving as the source of amino acids necessary for muscle repair and growth. When muscle fibers are stressed during resistance training, they develop microtears, which are an essential stimulus for adaptation. Amino acids from dietary protein are incorporated into these fibers to rebuild them stronger, more resilient, and more capable of handling future demands. The presence of these nutrients immediately after exercise is particularly impactful because muscle cells exhibit increased sensitivity to amino acids during this period. This heightened responsiveness, sometimes referred to as the anabolic window, allows for more efficient protein synthesis, reducing the duration of muscle fatigue and promoting structural repair. Timing protein intake ensures that the body can capitalize on this natural biological state, translating the stress of exercise into tangible gains in strength and resilience. Carbohydrates, often considered the primary fuel for exercise, also play a pivotal role in recovery. As muscles contract repeatedly, glycogen stores are consumed, leaving the fibers energetically depleted. Replenishing these stores post-exercise is critical not only for restoring energy, but for supporting the ongoing demands of metabolism and cellular function. Glycogen restoration also influences hormonal responses, particularly insulin, which acts as a messenger to promote nutrient uptake into muscle cells and stimulate the synthesis of new proteins. This interplay demonstrates that recovery is not simply about replacing what was lost, but about actively signaling the body to rebuild, reinforce, and prepare for subsequent physical challenges. The type and quantity of carbohydrates consumed influence how efficiently glycogen is replenished, with moderate to high glycemic index options often providing rapid restoration, while complex carbohydrates sustain energy over longer periods. Hydration continues to be essential in the post-workout phase, as water facilitates nutrient transport, regulates temperature, and supports enzymatic reactions critical for recovery. Fluid lost through sweat must be replaced not only to restore plasma volume, but to maintain the internal environment in which biochemical reactions occur optimally. Electrolytes, particularly sodium and potassium, play an equally important role in ensuring that muscles can contract effectively, that nerve impulses transmit efficiently, and that cellular homeostasis is restored. Rehydration is not a passive process. It is a critical step in supporting the intricate systems that govern recovery, performance adaptation, and overall health. The combination of water, electrolytes, carbohydrates, and protein creates a synergistic effect that accelerates restoration, minimizes fatigue, and primes the body for its next opportunity to move and adapt. The nervous system, often overlooked in discussions of recovery, also benefits from careful post-exercise nutrition. Neurotransmitters, which control mood, focus, and motor coordination, are influenced by the availability of amino acids, glucose, and micronutrients. Post-workout intake replenishes precursors for these neurotransmitters, supporting mental clarity, reducing perceived fatigue, and stabilizing mood. Sleep quality, which is critical for recovery and adaptation, is also enhanced when nutrient and hydration needs are met, demonstrating the interconnectedness of the physiological and psychological dimensions of restoration. Recovery, therefore, is not merely about rebuilding muscle, but about restoring the integrated system of body and mind to a state of equilibrium, ensuring that future performance is optimized. Antioxidants and micronutrients play a subtle but profound role in post-exercise recovery. Exercise induces oxidative stress, generating reactive oxygen species that can damage cellular components. While this stress is part of the natural adaptation process, excessive oxidative damage can impede recovery and increase fatigue. Nutrients such as vitamin C, vitamin E, and polyphenols from whole foods help modulate this stress, supporting cellular repair and signaling pathways that regulate adaptation. Minerals like magnesium, zinc, and calcium facilitate enzymatic reactions, nerve transmission, and muscle contraction, further enhancing the recovery process. The choice of whole, nutrient-rich foods post-exercise is therefore not incidental, but central to harnessing the body's natural capacity for repair and growth. The timing of post-workout nutrition also interacts with circadian rhythms and metabolic cycles. The period immediately following exercise is characterized by elevated blood flow to muscles, increased insulin sensitivity, and active nutrient transport mechanisms. Consuming protein and carbohydrates during this window maximizes the efficiency of nutrient uptake, accelerates glycogen replenishment, and enhances protein synthesis. Delaying intake may reduce the efficiency of these processes, potentially prolonging fatigue and slowing the progression of strength and endurance adaptations. This principle highlights the dynamic nature of recovery, where not only what is consumed, but when it is consumed, can have measurable effects on performance outcomes and long-term health. Psychological factors also influence the efficacy of post-workout nutrition. Engaging with the recovery process mindfully, paying attention to what is consumed, and how it is integrated into the broader context of lifestyle, can enhance adherence, satisfaction, and overall well-being. Preparing a balanced recovery meal or shake is an act of awareness, a recognition that the body's efforts during exercise are valuable and worthy of support. This perspective transforms recovery from a passive period into a deliberate practice of care, reinforcing the connection between action, nutrition, and physiological adaptation. The mindful approach to post-exercise nutrition reflects an understanding that the body functions as a holistic system, where physical, chemical, and psychological factors converge to determine outcomes. Recovery nutrition also serves as a bridge between immediate performance and long-term adaptation. By providing the necessary substrates for repair and energy restoration, it ensures that the body is prepared for subsequent sessions, reducing the risk of overtraining, injury, and cumulative fatigue. Amino acids and carbohydrates consumed post-exercise not only repair existing damage, but also signal the body to enhance metabolic pathways, improve mitochondrial efficiency, and strengthen musculoskeletal structures. Hydration supports these processes by maintaining the internal environment in which enzymatic reactions occur efficiently, facilitating waste removal and ensuring optimal circulation. In this way, post-workout nutrition is both restorative and preparatory, shaping the trajectory of fitness, health, and resilience. The integration of macronutrients, hydration, micronutrients, and psychological attention demonstrates the holistic nature of recovery. It is not a singular act, but a coordinated sequence of choices and processes that collectively support the body's inherent capacity to heal, strengthen, and adapt. Observing how recovery practices influence energy levels, mood, and performance outcomes provides insight into the body's intelligence, revealing that adaptation is guided not only by stress, but by the quality of support offered in the aftermath. Post-workout nutrition is, therefore, a form of collaboration with the body, a deliberate engagement with the biological systems that determine both immediate and long-term success. Ultimately, post-workout recovery is a lens through which we can observe the interconnectedness of all physiological systems. The muscles, nervous system, hormones, metabolism, and mind are engaged in a dynamic interplay that is influenced profoundly by the choices we make after exertion. Protein, carbohydrates, hydration, micronutrients, and mindful attention converge to create an environment that fosters repair, adaptation, and resilience. The simple act of consuming the right nutrients at the right time is both a scientific intervention and a compassionate gesture toward the body, acknowledging the effort invested during exercise and supporting the ongoing journey of growth, strength, and well-being. In this way, recovery nutrition becomes more than sustenance. It is a sophisticated practice of biology, awareness, and thoughtful care, allowing the body to continue its remarkable dialogue of performance, adaptation, and health. The foods we choose and the patterns in which we consume them carry effects that ripple far beyond immediate energy provision or muscle repair, touching nearly every system of the body in subtle and profound ways. Nutrient synergy is the concept that the combination of nutrients, their timing, and their interactions create effects that surpass what each element could achieve alone. It is not merely the sum of carbohydrates, proteins, fats, vitamins, and minerals, but the way they work together to optimize absorption, facilitate biochemical reactions, modulate hormonal responses, and enhance both performance and recovery. When approached mindfully, this synergy allows us to transform eating from a mechanical act into a dialogue with our own physiology, an acknowledgement that the body is a complex, adaptive system whose needs are both immediate and ongoing. Recognizing this interconnection encourages a sense of curiosity and intentionality, where each meal becomes a conscious act of engagement with the underlying intelligence of the human organism. Consider the interplay between macronutrients and their impact on energy metabolism. Carbohydrates provide immediate fuel for the muscles, protein delivers the amino acids necessary for repair and signaling, and fats support hormonal balance and long-term energy availability. When these macronutrients are consumed in thoughtful combinations, their effects are amplified. For instance, pairing carbohydrates with protein before or after exercise improves insulin-mediated uptake of amino acids into muscle tissue, enhancing protein synthesis and glycogen replenishment simultaneously. Fat, often underestimated in its influence, slows the absorption of glucose and supports the synthesis of steroid hormones critical for recovery and adaptation. The result is a more measured, sustained, and efficient metabolic response, reducing peaks and troughs in energy, improving exercise tolerance, and supporting systemic balance. Each component, while powerful in isolation, becomes transformative when integrated thoughtfully with others. Micronutrients add an additional layer of complexity and impact. Minerals like magnesium, calcium, and zinc participate in enzymatic reactions that govern energy production, muscle contraction, and nerve transmission, while vitamins serve as cofactors in hundreds of biochemical pathways. Antioxidants, present in colorful fruits and vegetables, modulate oxidative stress induced by exercise, protecting tissues from excessive free radical damage while also facilitating the signaling processes that drive adaptation and repair. Mindful attention to these micronutrients ensures that the metabolic and structural demands of the body are met comprehensively, supporting both immediate performance and long-term health. In this way, a meal is not merely calories, but a carefully orchestrated intervention, one that nurtures the body on multiple levels and reinforces the principle that quality and balance matter as much as quantity. Hydration intersects with nutrient synergy in ways that are often invisible but crucial. Water serves as the medium through which all nutrients are transported. Enzymes catalyze reactions, and cells maintain homeostasis. Electrolytes dissolved in fluids, sodium, potassium, magnesium support nerve conduction, muscle contraction, and fluid balance. The combination of hydration and nutrient intake ensures that the body can efficiently absorb, transport, and utilize what has been consumed. Even small imbalances, such as insufficient fluid or electrolytes, can blunt the effectiveness of nutrition, slowing digestion, impairing energy delivery, and reducing the efficiency of metabolic processes. The recognition of this interplay emphasizes that nutrition and hydration are not separate considerations but intertwined aspects of a single system, one in which every choice influences a cascade of biological responses. Timing remains a critical component in mindful nutrient synergy. Consuming nutrients in proximity to exercise before, during, and after ensures that muscles, nerves, and other tissues receive the substrates they require when they are most receptive. Protein and carbohydrate intake immediately following activity, for example, capitalizes on increased blood flow to muscles and heightened insulin sensitivity, accelerating recovery and promoting adaptation. Even micronutrient absorption can be influenced by timing, as certain vitamins and minerals are better utilized in the presence of specific macronutrients or under conditions of heightened metabolic activity. Observing how the body responds to nutrient timing and making adjustments based on personal experience transforms the process from a static plan into a dynamic, responsive practice, one that deepens awareness of the body's needs and capacities. The psychological and cognitive dimensions of mindful nutrient synergy are equally profound. Eating with awareness, observing how different combinations of foods affect energy, mood, focus, and physical performance creates a feedback loop that informs future choices. The act of preparing and consuming balanced meals becomes a practice of attentiveness, teaching patience, observation, and respect for one's own biology. These behaviors reinforce the understanding that nutrition is not merely functional but also integrative, influencing not just muscles and metabolism but also mood, cognitive clarity, and emotional resilience. A person who cultivates awareness in their nutritional choices begins to notice patterns in energy fluctuations, mental focus, and performance that might otherwise go unrecognized, and can adjust intake to optimize both physical and psychological states. The concept of synergy also extends to the subtle interactions between nutrients and the gut microbiome. Emerging research highlights the critical role of gut bacteria in nutrient absorption, energy regulation, immune function, and even mood modulation. The combination of fibers, prebiotics, and diverse nutrients in a balanced diet supports a healthy microbial ecosystem, which in turn enhances digestion, facilitates the synthesis of vitamins, and modulates inflammatory responses. In this sense, every nutrient choice participates in a broader ecological system within the body, one that communicates across tissues and organs to optimize health and performance. Mindful nutrient synergy, therefore, is not only about the immediate effects of food, but also about cultivating the internal environment that sustains long-term adaptation, resilience, and well-being. Furthermore, nutrient synergy underscores the principle of balance over extremes. Excessive intake of any single macronutrient or supplement may disrupt the delicate coordination of systems, whereas thoughtful combinations maintain equilibrium. Carbohydrates, proteins, and fats, when balanced appropriately, ensure that energy is available, recovery is supported, and hormonal function is stable. Micronutrients, antioxidants, and hydration act as modulators and protectors, enhancing the body's capacity to adapt to stress and recover efficiently. Observing how different food combinations influence subjective experiences of energy, recovery, and performance allows individuals to refine their approach, developing a nuanced understanding that integrates both objective science and personal experience. Practical implementation of mindful nutrient synergy involves both planning and responsiveness. Meals designed to support performance and recovery should consider the types of exercise, timing relative to activity, and individual tolerance. Pre-workout meals may focus on rapidly available energy sources. Post-workout intake emphasizes protein and carbohydrate for repair and glycogen replenishment. And throughout the day, balanced meals provide micronutrients and sustained energy. Hydration, electrolytes, and antioxidant-rich foods complement these choices, ensuring that biochemical pathways are supported, stress responses are modulated, and the body remains in a state conducive to adaptation. Attention to portion sizes, food quality, and timing transforms eating into a deliberate practice, one that aligns with the body's natural rhythms and demands. There is also a contemplative aspect to this approach. Considering each meal as a form of dialogue with the body invites reflection on the interconnectedness of biological systems. Energy, recovery, cognitive function, and emotional state are all influenced by nutrient synergy, and observing these effects cultivates insight into the body's intelligence. This reflective practice encourages curiosity, patience, and a deeper sense of stewardship over one's own health, where choices are informed by both scientific principles and lived experience. Each bite becomes an opportunity to nourish, to optimize function, and to respect the remarkable complexity of the organism we inhabit. Mindful nutrient synergy extends into long-term health outcomes as well. Proper integration of macronutrients, micronutrients, hydration, and antioxidants reduces chronic inflammation, supports immune function, and promotes resilience against stress. By consistently providing the body with balanced and complementary nutrients, we create conditions for sustained energy, cognitive clarity, and physical capability. The compounding benefits of these choices accumulate over time, enhancing not only athletic performance but also overall well-being, longevity, and quality of life. Nutrition, in this sense, becomes both a tool for immediate physiological support and a foundation for enduring health. Finally, mindful nutrient synergy represents a philosophy of care and attentiveness toward the body. It embodies the recognition that the organism is not merely a machine to be fueled or repaired, but a living system whose performance, recovery, and adaptation are shaped by thoughtful engagement with its environment. By observing how nutrients interact, responding to the feedback of energy levels, focus, and physical sensation, and integrating hydration, antioxidants, and balanced macronutrients, we participate in a continuous dialogue that enhances performance, supports recovery, and nurtures resilience. This approach combines the rigor of scientific understanding with the awareness and reflection of lived experience, transforming nutrition into both a practice of health and an act of mindful stewardship. In embracing nutrient synergy, we honor the complexity of our biology, optimize our capacity for movement and adaptation, and cultivate a deeper, more conscious connection with our own well-being. This content is for general educational purposes only and is not medical advice. Always consider your health condition before starting any workout. If you have any medical concerns or pain, consult a qualified healthcare professional.